Welcome. If you've been following my channel, would have seen me reveal this part, which I've cast on one of my shorts. Now this is the 2-axis swivel. Uh, this section here is going to slide down the post of the attachment, and on this end you'll have your swing arm that's going to swivel on it on this end, or you're going to have a general purpose tool holder that will give you a vertical access to change your cutting angles. Say for argument's sake you want to grind a piece of high-speed steel and you want to give yourself back relief, you can adjust your angle vertically. Horizontally it will turn around the post, so that will give you that option as well. Now this casting, because of it being a casting, it's full of draft angles. You have a draft angle here, it's around 2 degrees, and it extends all the way from the over the length of the part. Now I've overfilled it because of if there's any shrinkage, that it doesn't affect the thickness of the part. So it left me now with a lip around the side edge here, and there's some minor imperfections on the side. Now the problem that I sit with is I cannot put it straight into my forge or chuck, because there's just not enough jaws to grip it. Let me just take this out of the way. If you look at it, the amount of jaws it's going to grip on the side here, if I do want to machine it as is, the face of this end here, I'm going to have an accident and hurt myself, because it's not going to stay in the chuck. So my only reference surfaces that I've got that I can use on this hull casting that's more or less square is these two sides here. So my first order of operations will be to face off the top and center drill it, and then I can move back into my forge or chuck, because then at least we'll have a tailstock support to keep it from flying out of the chuck. Now my setup here is very simple. It's got 1, 2, 3 blocks that the part will rest on. I've put 2 very thin pieces of shim on the one side here, because it's got a slight bow imperfection in it, but other than that it's solid. And then I'm going to use one of my H clamps to clamp it down. Mill this section clean on this side here. Put up strap clamps on this end here, and mill the remaining surface on it, and Bob's your uncle, it's done. Then I can center drill it and put it back into the chuck, and then clean up this entire outer face here, all the way up to this point here. So yeah, it's tricky, but where there's a will, there's a way. Okay, if you're wondering why I've got such a wide V configuration here, it's to give me access with my edge finder so that I can get into the 90-degree planes. It will allow me to get access to the part. So I can just drop the edge finder down in between. So I've got nothing in my way. Alright, I made a blunder. The last cut on the outside on the Audi that I've taken was one cut too many, and it landed up a little bit undersized. I'll make a nylon bush that's going to fit over it, so it will serve as a bearing. So I don't think that's a massive train smash. Okay, you saw me do a lot of things here, and if you're a machinist, you'll know exactly what I've done. If you're new to machining, you probably have questions, so I'm going to answer them quickly. So what I've done is I've put my rotary table's position 0 on the mark. Then I've leveled it with a inclinometer that is 0 to the bed to get the parts more or less straight or level. Then indicated the parts, so this rounded edge here is running concentric to the spindle of the rotary table. Then went back to verify that it's still 0. Zeroed it and zeroed my rotary table, the dial at the bottom. So everything is zeroed, and this reference plane here should be leveled and have the minimum amount of machining needed to get it flat. So if I rotate it 180 degrees, I should be able to machine the bottom end, coplane it to the top. So that's what I've done in a nutshell. So what I'm going to do is I'm going to take it down close to the side here. Then I'm not going to finish up this face here immediately. So I'm just going to take it down, see how much I need to clear. There's a little bit of inclusions here in the tip. See how much I need to take off to get past that. And then flip it around 180, cut the same depth, and then move into the shoulder for a clean-up cut here on the side. Flip it back 180 and do the same cut again. So everything should be then 100% equal. Hopefully it makes sense. You should see when I do the machining. Now if you're wondering why I'm doing it in on a rotary table and not a vise, is because if you want to use a vise, you can only clamp it on this little lip here, and you have the risk of damaging it, and you still have a risk of getting run out or being off square. This is a trick that I've learned from the Max one. So he's doing a lot of parts in the rotary table, especially complicated parts, which is difficult to hold in a vise. And I found that this method works very, very well. Just have a little jack in here at the bottom for support. So yeah, let's get started here. One thing that you need to note when you do edge finding on the part that is cut rounded edges is that the Z height needs to be exactly the same all around. So I'm not going to touch the quill. I'm going to leave it as is and just move the edge finder around the part up to this point here. And then when you use your half function on the DRO to find your center or the center line, that measurement that you're getting there will be exactly the same measurement that you need to use from the front back into the part to be exactly in the middle of this radius. I'm not going to show the edge finding process. I've done it a couple of times already. So I'm going to do that off camera and bring you back for the hole in the middle. Okay, now I can turn it 90 degrees and do the clamping bolt on the side. Just going to use a visual cue to get center. It's not that critical. Now, because of the rotary table, I don't have to find center every time I do a rotation or anything, because it will stay in the same plane. Okay, the cutter grind attachment is beginning to take shape. Now, here's my locking collar from the second video. Now that will hold the two-axis swivel joint at a specific height. So for argument's sake, if you have a tool in here and you need to round off an edge, you can do that. And even with, say for argument's sake, on my attachment that I need to install, if you need to cut specific angles, say for argument's sake, you want to make a thread cutting tool or grinder thread cutting tool, then you can adjust your angle. And you can adjust the angle, your back relief. That attachment will come later on. This one is primarily for drill bits and for end mills. So this way you'll be able to cut your relief, your back relief, specific angles. I must still make my indexable plate that goes on this end, and your angle you can set here in the back and lock it up with a set screw. So yeah, hopefully the build is starting to make sense. You just see or saw a whole lot of parts and not knowing what it's for. My mistake was easily rectified with a nylon bushing there, and there's absolutely no play on that joint. It's a bit stiff, but it can rather be stiff than loose. And on this end, if you lock it up, then it's also solid. I still haven't made my T-nuts. All the little odds and ends I'll make in a separate video to complete the build. So I hope it was entertaining and insightful. Until next time, cheers.